Alright, so now what we're going to do is we're going to talk about what we call the inverse trigonometric ratios. And this is a way to calculate any acute angle if you know the ratio of sides. And it's pretty much a calculator problem. But first we got to figure out how to set this up. So first off, we need to figure out what we're doing in this case. Now I'm going to go back to the 3, 4, 5 triangle, and I'm going to actually label it right this time. ABC. Let's say that's 3, that's 4, that's 5. And the question is, what is the measure of angle A? And this is something that you're going to be asked to do. And probably sooner than later. Now, one thing that we know is that the sine of angle A is what? If I'm talking about angle A, the sine is going to be my opposite over hypotenuse. So what's opposite angle A? What's the value? 3. And what's the hypotenuse? 5. It's the biggest one. Now, we want to get to angle A here. And the thing is, we need to have what we call an inverse operation. Think of adding. What's the opposite operation of adding? Subtracting. Like if you add 2 and then subtract 2, you're right where you started from. So the idea is, alright, well, is there an operation that we can do that's going to basically undo the sign? Like division undoes multiplication. Taking a square root undoes squaring a number. And we do have one. It's called an inverse trig ratio. So here's what's really going to happen. So I'll take the sine of A. This is just rewriting. Leave a little bit of space there. Here's what's going to happen. I'm going to use this function right here. And it looks like sine to the negative 1 power, but it's not really sine to the negative 1 power. This is referred to as the inverse sine function. And if I take the inverse sine of both sides, the idea behind this is the inverse sine of the sine of A is equal to whatever A is. It's like doing adding and subtracting. It's like taking a number, adding 2, then subtracting 2. You get right back to the number. So the sine and the inverse sine basically cancel each other out. So whenever we have anything like this, start with writing a trig ratio. Then 2, use the inverse of that, because what's going to happen is this sine and that inverse sine cancel each other out, and I'm left with the measure of angle A is equal to the inverse sine of 3/5. And that is when we use a calculator. going to show you this. It's an arrow, like an arrowhead, but it looks like a triangle. It's going to be in your calculator, but it's a big arrowhead. And this is going to be an operation that is going to say, all right, give the answer in degrees. So this is going to be an important thing for us. So let's go first to our calculator. Now the reason why I tell you that is because your calculators might not be in degree mode. Some of them are, some of them aren't. Yes. Yep. Primarily because every other class that I teach uses what we call radians. So we want to make sure that our answers are in degrees. Now, for example, if I wanted to take and over here is the trig button right next to 7. If I just wanted to do, like, in the top row are my sines, my cosines, my tangents, and then the 3 other ones that we're not going to deal with. But if I just use the sine, and I say I want the sine of 40 degrees. Now, since I don't know for sure if 40 degrees, or if the calculator is actually in degree mode, up here in blue above the book key that's a couple to the right of the 9, if you hit Control and then book, there's 2 things that we're going to use. There's that arrow that I was talking about before, and here's the degree marker. So you can use the degree marker, and now we're telling the calculator, find the sine of 40 degrees. So it's basically using the correct units in that case. And then you hit enter, and then you get 0.642788. Now, another way that you can get to the degree is by the G button down here. It has the question mark, the exclamation point. If you hit that, it has like a $sign, and then there's degrees. And it actually has minutes and seconds, but we're just dealing in degrees right now. So if you wanted to get to the degree, you can get there as well. So there's a couple different ways you can go about doing that. But now, let's go back to the problem that we had. We wanted the inverse sine of 3/5, but we want our angle in degrees. So we go to trig. Everything's going to start with trig. We hit sine, inverse sine, and then you just type in 3 divided by 5, and then close parentheses. Now, to make sure that our answer is going to be in degrees, here's what you need to do. Hit Control Book again and go to this arrow and put in the arrow. And then just put in 2 D's. The first D that we wrote was italicized. And when it's like that, the calculator doesn't know what's going on. But as soon as it straightens up like that and you see arrow DD, what's going to happen when we hit enter is we're going to get our answer in degrees. And we get 36.87. Now, if we just said, I want the inverse sine of 3/5, and you get something that looks like this, your answer, that's in radians. So that's a different way of, actually measuring things. So if you get weird answers that are really, really small like this, that are 1 or 2, as far as answers, anywhere from like 0 to like 2, you're in radians, and you have to put it into degrees. Yes.
So how did you get CB again on this trig?
All right. So I'll put I'll put 0.6 because that's what 3/5 is. Now the arrow is located. Go Control Book, and you're going to get all the different symbols, and the arrow is in the first row. And then you just type DD. The first D is italicized, but the second one, the calculator will recognize it as something, a function that it needs to do. And then you'll get your answer out of that. Yep. Now, most of the time, like for these, the nice thing about this would be if I want to find the measure, I'm just going to take and say the measure of angle B is, since I'm using a sine, I need to use an inverse sine of 0.4848. So I'm going to type that into my calculator, but make sure that I put my arrow DD afterwards. Once I type that into the calculator, that'll give me the answer that I need to get. And for like measure of angle A here, since I'm using a cosine, I'm going to use the inverse cosine of that 0.7431. And remember just to go triangle DD, and then you'll get your answer. So that's just, for those, you're going to do the same thing over and over and over again. Scientific calculators have the inverses as well. Just make sure that you're in degree mode, because you could be in where it says DEG, that's where you want to be. If it says RAD, rad, that's in radian mode. That's a different way of measuring an angle that we'll talk about when we get to circles. You need to know stuff about a circle before you can talk about radians. Now down here, there's the angle that I'm looking for. They're going to give you a couple sides. Now, for example, what side is this for this acute angle right here? Is that the hypotenuse, the opposite, or adjacent? Yep, that's my opposite. Now, what's this side that they gave you? The adjacent. Now, for SOHCAHTOA, which one has the opposite and adjacent? And remember, you're just kind of looking at these two. Which one is it, sine, cosine, or tangent? That has opposite and adjacent. Yeah, it's the tangent. So the tangent of whatever that angle is going to be equal to the opposite side, which is 27, over the adjacent side, which is 38. Now, if I'm using the tangent, what inverse trig function am I going to use to figure out what that angle is? If I'm using the tangent, which one do I have to use? Well, if I use the sine, I use the inverse sine. If I use the cosine, I use the inverse cosine. So if I have a tangent, I'm going to use the inverse tangent of 27 over 38. So your job is going to be to first come up with the trig ratio. And that whatever you're going to use there, the trig ratio, if it's a tangent, use an inverse tangent to get to the angle. Now, remember, if you're still having problems figuring out what's what, I always say go for the hypotenuse first. Like, for example, this guy, the hypotenuse is this line right here. That's my hypotenuse. Because then you can figure out opposites and adjacents a little bit better. The highlighter's not working too great as far as that goes. But for this guy, here's the hypotenuse. This guy, this is your hypotenuse. (13 and 14), that's your hypotenuse. 14, there's your hypotenuse. So at least now, if you have a value for your hypotenuse, like this, you're going to end up using a sine or a cosine. If you have no value here, which one of the SOHCAHTOAs has no hypotenuse in it whatsoever? Well, which one doesn't have an H? The tangent. So for number 11, whenever you don't have a value for the hypotenuse, like I know I'm going to use a tangent. Number 10, does it have a value for the hypotenuse? No, so you're going to use a tangent. So if we're going to use the tangent to build this, we have to figure out opposite over adjacent. We're going to end up using the inverse tangent. So since I'm using a tangent here, I'm going to use an inverse tangent. Now for these, we got to figure out, alright, do I have an opposite? Since I have a hypotenuse, is this an opposite or adjacent? Is that 40 an opposite or an adjacent? Yep, it's an opposite. So the opposite, the one with the O, is going to be the sine. So I know the sine of whatever that angle is 40 over 42. So I have to use the inverse sine of 40 over 42. And that's going to be equal to whatever my value is going to be. So your job is to figure out which trig ratio you have and then use the inverse of it to figure out the angle. So you have the rest of the time to work on these.